ProClimber inspires and educates people to create healthy, durable and energy-efficient buildings to live, learn, work and play in. Welcome to the ProClimber podcast. In today's episode, I speak with Andre Heller. Andre is an industrial designer who developed a revolutionary method for the manufacture of prefabricated homes. In this interview, we hear about how he used his experience in boat building and underground stations to design high-performance construction panels. All right, Andre, well, welcome to the ProClimber podcast. How are you doing today?
Awesome, Simon. Nice to be here. Thank you.
Now, Andre, just to give our audience a little bit of a picture about you, whereabouts in New Zealand did you grow up?
I grew up here in Wellington. So, based in Lower Hutt, sort of born and bred here. But I've lived also down in Invercargill, which we'll no doubt dig into.
Yeah, of course. That's a little bit of a different climate down there.
Oh, yeah, very cold.
And growing up in Wellington, the house that you grew up in, what was that like? Was it comfortable? Was it warm in winter and cool in summer?
It was warm because the heating was on most of the time, I suppose. So my parents have a 1950s sort of timber weatherboard house, pretty typical for New Zealand sort of standards. But yeah, I suppose I remember growing up with the heaters on a lot, especially cold winter mornings, sitting in front of the heater, putting your clothes on to go to school and that sort of thing. Summer, not so much of an issue with overheating or anything like that, but yeah, definitely remember it being quite chilly in the mornings during winter.
Now, when you finished school, you went on to study a Bachelor of Design majoring in industrial design. What was it that motivated you to move down that path?
Between sort of school and university, I ended up taking a year off school, between school and uni, and just wanted to find my feet a little bit. And I actually did a year of builder hammer hand labouring type work. And I suppose my family's always sort of been in the creative spaces. My sister went and did graphic design. And so I knew I was sort of in that space. I'd always done photography and art and that sort of stuff at school, a lot of woodworking. That led me to the design space and construction space. And I didn't really know exactly what I wanted to do, but I knew it was in that design space. So I did a Bachelor of Design at Massey University in Wellington. And then after the first year, you sort of start to specialise, and ended up specialising in product design, which was just a perfect fit for me in the end.
And after that, you went into the marine industry, and then you moved over to the UK and you joined a company called Bryden Wood. So what did you take from those two experiences?
With my university degree doing product design, I majored in industrial design and designed a spearfishing watercraft. So that experience led me to Invercargill to work for Stabicraft, where I was designing boats for them. This was a internal design and manufacturing company. So I got to understand manufacturing from, I suppose, the ground up, like embedded right into a manufacturing model. And so everything that we did as designers had a direct manufacturing outcome. And then from there, I did a few years with Stabicraft and ended up moving over to the UK with my partner at the time, now my wife. And we're just sort of doing a bit of traveling and that sort of thing. And I was looking to get into super yacht design. And I ended up getting a job with Bryden Wood, which is a multidisciplinary architecture firm with all sorts of engineering and different practices within the one firm. And they were doing something quite unique and different. They were actually hiring product designers and industrial designers to help them with manufacturing of construction projects. And so they developed what they called at the time a systemization team. And we were effectively a group of product designers led by an engineer. And the projects that we're working on were Crossrail, the underground train station or stations and train line going from Heathrow Airport right through out to the east of the UK, right through Central City. And we designed and detailed the underground train stations and their cladding systems for glass fibre reinforced panels. And then that sort of experience that we developed as a team for that specific project ended up developing into how we applied solutions for high-rise apartment buildings and designing and building facade panels for buildings, brick slip systems, all sorts of different cladding systems. I suppose the unique thing there was everything was a large focus for offsite manufacturing, applying a design for manufacturing approach or a platform design approach, and creating these unitized panels or prefabricated parts that had simple installation on the construction site.
So, what were the benefits of the prefabrication over actually building it on site?
A lot of it comes down to speed, time, efficiency, reliability, dependability on what's delivered, and increasing the quality of the product delivered. So yeah, really flipping the conversation from, hey, we have a construction project and we'll build this on site with raw material. It's no, we're actually building high quality components, products in a factory and mass manufacturing those it opens the door to scale. And when you're doing these massive infrastructure projects, time is money. And the only way to build something at such a large scale like this is to mass manufacture it.
And then you decided to move back to New Zealand. What was the decision there?
My wife and I, we always wanted to move back. It was never really the plan to live overseas permanently. We're doing the typical Kiwi OE experience sort of thing. So we did a couple of years over in the UK and Europe. And yeah, we moved back home sort of 2015. And I suppose that at the time I wanted to continue doing the work that I was doing. So I stayed on as a contractor and got to work on all the same projects effectively that was sort of scattered all around the world and Europe and that sort of thing. So it was a good opportunity to carry on doing the work that I really loved and enjoyed, but then move back home and have the lifestyle. Fishing, hunting, diving, all those sort of good things.
It's really amazing these days how you can sort of work remotely and have the lifestyle as well as the job, isn't it?
Yep, absolutely. It's pretty good.
So the business Flexi House, how did you come up with that vision?
I suppose it stems back to that sort of arrival back home, and after I suppose this time and experience that I gained overseas in the offsite manufacturing space and this different way of construction, applying a product approach to construction, I sort of came back and saw the state of our sort of construction industry, saw the way in which we were building housing, and it was still pink stick timber on site. And I was kind of shocked. It's almost like I knew it because I'd kind of seen it and been in it 5-10 years earlier. But it was really quite amazing that there wasn't offsite construction that existed in New Zealand, or at very, very small amounts, And so that sort of encouraged me to explore what an offsite model might look like here in New Zealand. And that kind of, that was the beginnings of Flexi, I suppose.
You talk a lot about the benefits of offsite construction. So obviously, stick frame is what everyone's been doing for many, many years. We've seen different offsite manufacture in New Zealand. Some of those have come and some of them have gone. What was your plan and what did you think was going to happen in your business that was going to be different to some of those other ones that perhaps didn't make it?
So I think the key thing is applying a kit of parts approach or a product design approach to housing. I suppose I'll talk a little bit about the birth of Flexi and where it started and why. I was frustrated at the high cost of construction and housing in New Zealand, and I wanted to see if there was a way that if you could start with something small and high quality and then add to it over time, it'd be a really great way to build your dream home effectively. So you're not having to purchase a home and it need $200,000 or $300,000 of renovation, and you're always fighting against changing materials and this sort of thing. So I wanted to develop a solution effectively, where you could start with a small 1 or 2 bedroom home and be able to add to it over time, room by room approach, but make sure that the core building or the core starting point was of really high quality. So you're not having to do those renovations and changes over time to increase the performance or anything like that. So that was probably the starting point for Flexi. And, we've grown and developed a lot over the last sort of 5-6 years, and our model has changed a little bit. But some of the key, I suppose, differentiators, or maybe before the key differentiators, I actually explored a lot of different systems and way in which we could build new housing for this modular staged type approach or this growth approach. So, looked at different SIPS panel systems, CLT systems, timber frame systems, post and beam, mass timber systems. And I really wanted to dig deep into what was going to be highly scalable and what was also understandable by the mass market. What could every builder in the country pick up and understand, and how could we really develop a system that any builder in the country could really use or build with? And so that led me down the timber frame route, because it's something very familiar to builders. And so we developed a really lightweight timber frame system, lightweight being key from a timber fraction point of view. So the less timber there is, the more insulation there can be. So we're not overfilling the frame with timber. And then I suppose quality had to be paramount. And so creating a really high quality envelope and a bulletproof envelope system where we can significantly de-risk construction and make these buildings durable for not just, the next 10 or 20 years, but make them durable for 100, 200 years. Going back to some of the construction projects that I was working on in the UK, they've got a timescale of 200 years. We don't think like that in New Zealand. We think about how long is this building going to last? Oh, it's got a 10-year guarantee. That's crazy. 10 years is nothing. I've been, working on this company for the last 10 years almost, you don't want one of your houses being up for replacement in 10 years' time. So quality and the durability of the system is absolutely paramount. So that's one, I suppose, key differentiator, is building a really high quality product that will last the test of time. But also when you apply a offsite manufacturing approach and a product approach, you can really hone in on the cost of the system and have really good cost control. You look at an iPhone, every iPhone is exactly the same price. It's not like when you go into one store onto another store that they're different prices. They are all, $1,500 or whatever it is. That is the retail price. Why can't housing and construction be like that also? Why can't we treat it like a product? It's really hard to do, but with offsite construction and a manufacturing approach, we can get a lot closer to that and offer a highly accurate pricing model and cost control model, which is quite interesting.
So can you dive a little bit deeper into the build-up of the panels? What is the actual makeup of these panels and how do you put them together?
It all stems back to, I suppose, creating the ultimate system and a bulletproof, high-quality, durable system. And so, we wanted something that could last the test of time. And so you have to flip the model on its head. You have to assess what we're doing currently and see that, yes, okay, that works right now, but is that going to work in 50 or 100 years? And so what I wanted to do is, really flip the system on the head and go, right, what is the right way to do it? Not what's done currently, not what we know right now, but what is the most efficient and bulletproof system long term? And so you, of course, start looking into things like thermal performance and energy and carbon of buildings. When you start thinking long term, the conversation really flips from what is quick and cost effective right now to what's the long-term cost benefit. And so that led us down the route of digging into the performance of the building and what does that mean and what does that look like. And so we wanted to create a sort of an optimal thermal envelope. And the way in which we've done that is we've focused on continuous insulation and continuous layers. And I'll talk about a few of those. Starting from the outside is having a continuous weather-resistive barrier, having that a really high-quality, durable barrier on the outside of the building, and then having a continuous insulation layer in behind that so that we're not leaking heat through the walls of the building or the roof or the floor. And then on the inside of that, having a continuous vapor control and air tightness layer. And so having these three layers means that we can create a really high quality controlled envelope. And then we've got an internal environment that we can start to control as well through the likes of mechanical ventilation and quality heating solutions and that sort of thing. But digging into the actual build-up of the system, starting from the outside, so we've got this really high-quality weather-resistive barrier. So we're obviously using ProClimate products. So we're using the Mento on the roof, the Extasana on the walls, and we've started using Adhero as well. And we have these products over top of a rigid air barrier system. So we use a plywood system, so on the roof and on the wall, and also sometimes underfloor as well. So we create this continuous airtight external weather resistive layer, and then this rigid air barrier layer. And then on the inside of that, we're using really high quality insulation like Terralana wool insulation, really high performing insulation. And we've got that continuous. What I mean by continuous is instead of having a flat ceiling in a traditional house, we've actually pushed our envelope and our thermal line in the building right up to the rafter line or to the pitch of the roof. So this does a couple of things. It creates a singular internal air environment or thermal environment, but it also means that we get these beautiful open raked ceilings all throughout the building. We're controlling the internal air environment on the inside really well, but then also we're giving these beautiful, great architectural outcomes. So it's just an absolute no-brainer, and it's really great. And then on the inside of that insulation, we've got this air tightness layer, which we're obviously using the ProClimate and Tallow. And then on the inside of that, we are doing a 45mm service cavity, or sometimes up to a 90mm service cavity for ducting and that sort of thing. And what this does, it means that we can have all our services routed through the entire envelope without disrupting the insulation or disrupting the air tightness layer. And so that just helps provide a good space for electricians and plumbers to route all their services, without disruption. And then another key thing that I suppose I didn't really touch on before, above the sort of weather-resistive barriers, or on the outside of the weather-resistive barriers, we've got ventilated cavities. It's really common to have a ventilated cavity on the wall now in New Zealand, whether it's a 20mm or 45mm. We're using a 45mm vented cavity for wall cladding. But then when we go to the roof, we're doing something slightly different, or something that's not really used at volume here in New Zealand, but it's definitely the right way to go, and that's above sheathing ventilation. And effectively, it's a counter-batten system. So we use a vertical batten on the roof over top of our weather-resistive barrier, and then we have a counter-batten or a purlin over top of that. So it creates a huge amount of airflow in that roof space. And then we vent the roof space at the ridge and at the eave as well, and at the barges. And so what that means is we've got continuous airflow through that roof space or through that roof cavity, which just promotes drainage and drying, and so that we never have moisture build up in that roof space.
So you've talked about ventilating the cavities in the roof and the wall. What about the inside of the building? Obviously, you've got this air tightness layer. How are you ventilating the home itself?
On some smaller homes, we've done like decentralized heat recovery ventilation systems, and on larger homes, we do a full ducted ventilation system, so like a Stobo-Eltron system. And these systems, what mechanical heat recovery ventilation does is it takes the warm air on the inside of the building that's full of moisture, and we want to get that moisture and all of those stale smells and that sort of thing. We want to get that out of the building, but we don't want to lose all that heat that we've generated inside the building. And so what the heat recovery ventilation does is it pulls in fresh, cool air from the outside. And then as the warm, stale and smelly air on the inside goes past that cool air, it transfers the heat from the hot air to the cool air. And now that fresh air coming in, which is cold, is now getting passively heated through this heat transfer system. So you're maintaining the temperature within the building and creating a nice fresh air environment. So these are just trickle ventilators. They're running continuously all the time, making sure you've got the optimal air environment inside the building. So you're removing moisture, you're removing the smells, and you've got continuous fresh air coming in.
So I'm assuming that you're modeling the energy performance of these buildings. What is the performance that you're aiming for?
I think performance is something that's just is not commonly addressed in construction in New Zealand, not at scale anyway. And so we've just recently had these new H1 changes to energy efficiency of housing. It's a very small step in the right direction, but there's definitely higher performing ways in which we can address things. And one thing is doing energy modelling. And so we've done energy modelling of the likes of our show home in Cromwell, which if anybody's interested in going to have a look at, they're more than welcome to. So yeah, we've done some energy modelling on that building, and we found that it was 46% more efficient than the new H1 changes. And this is going back to 2022, and the new changes came out, I think, was it? Yeah, late 23. So when we did that modelling, we were testing to see how well is this building going to perform. And we actually proved that it's going to perform 46% better than all of the new houses getting built that meet the minimum legal standard, right? So that's I suppose, our base point. That's where we start, but that's not necessarily what we can achieve or what we are achieving. So we're actually working on a passive house at the moment in collaboration with another architect. So there's no reason why a passive house can't be. In fact, this type of system actually lends itself really well to passive house because it's doing all of the things that a passive house inherently needs to do. So yeah, I think in terms of performance, we range anything from that sort of 46% more efficient than traditional right through to passive house level standard.
Now, you've talked a lot about these panels. Are they standard size panels that people choose and then build up a home, or is this a more customized approach?
Yeah, so initially we looked at doing a really structured modular kit of parts approach where we had standard sizes, a 2.4 module, a 3.6, 4.8, and just worked up in sizes like that. And what we found is that although it was really interesting and it created some interesting ways to design, it was a little bit restrictive. So we sort of flipped the model on its head and started going, well, what's a right balance between what an architect draws and what we can supply and deliver with a panelized approach? And we found that it's good to follow some rules and it's good to follow some logic and structure, but at the end of the day, the most efficient way to install panels is the more panel you can install on one segment, the more efficient it is on site. So you're reducing your HIAB time. And so what we found, the ideal panel size is a 6 meter long panel by 2.4, 2.7, 3 meter high, whatever the stud height is. That is what we've found to be the ideal size. And that's because it fits on the back of a truck really nicely. And then we're installing a really high quantity of wall into a project really quickly. And we've talked a lot about walls, but I think one of the key things with our system is it's not just a wall system, it's actually floor, wall, and roof. So when we start talking about floor panels and roof panels, now we also have to think about what's the limitations of transport and trying to work into these 6x3 panel sizes as being the most efficient. And so, yeah, it's a really interesting way to start thinking about design. And we've got a whole lot of guidelines around the most efficient ways to design. But effectively, we can work to custom architectural designs and we can respond to those quite nicely and provide some really good solutions.
So are there any limitations to what you can do with this panelized system?
We're finding that we're actually enabling architects and engineers to do some pretty interesting things beyond what you can do with traditional construction. Because we use a LVL timber for all of our structural framing, it means we're actually getting much larger spans than you would get with, say, SG8 timber framing. Yeah, so we're able to achieve some pretty cool things, like with our living sort of spaces. If you think of a 6 meter wide by 14-meter long living space. Like that's a very big living space. You might have kitchen, dining, living in that area, but a very common sort of building typology these days is this gable aesthetic with these big, long, open plan kitchen, living, dining spaces. So if you imagine one of those big spaces, you would typically have all of these steel portals, these big ridge beams, everything like that to support this sort of open structure. With our timber panel system, we're actually achieving these sorts of, 14 by 6 meter open plan kitchen, living, dining spaces with no steel portals and no big ridge beams, 3, 4, 500 deep ridge beams. So we're using a 190 or 240 LVL, and we're able to achieve these really great spans. So limitations, there's not a lot. We're actually enabling some really high quality outcomes.
We hear about a lot about the levels of waste that's created by construction industry in New Zealand. Are there benefits of waste reduction and recycling within your system?
I suppose a good example of that is just looking at the timber content itself and the timber waste itself from a timber panel that we create. One of our most recent projects, we've got 2.5 small buckets of timber offcuts. And I'm talking about like 50, 100 mil sort of offcuts, like really small amounts of offcuts. So with this offsite manufacturing approach, we're getting high levels of efficiency of timber usage, so significantly reducing the waste that goes to landfill. But also when you're in a controlled manufacturing environment, all of your offcuts and all of your, whether it's a sheet offcut, a paper offcut, or the packaging that materials come in, everything can actually be managed and either reused in the next project or in other projects or in other parts, or it can be properly recycled or redeployed to the right location. So this type of approach really helps manage waste in a proactive way.
And are you manufacturing these panels yourself?
We are not. And I suppose that is probably one of the key things to our model. When I started Flexi, I was obviously doing a lot of research around modular manufacturers and offsite manufacturing in New Zealand. And there's a very common trend that a lot of offsite manufacturers end up going under or into liquidation. There's a graveyard of modular home builders. And I wanted to unpack that and understand why. And so I interviewed a bunch of them and tried to really understand why it was. And these guys or these manufacturers, they'll build the facility, and then unless you've got that volume coming through continuously, you've got a huge operational and capital expenditure sitting there. And so it was something that I addressed as that's the biggest risk point for a business like this. And so I was like, how do we actually flip that on its head, and how do we de-risk it? And how do we actually help provide a good solution to manufacturers in New Zealand? And so I suppose I've looked at what's called a contract model or a contract manufacturing model, which is very common in the product design space, but very uncommon in the construction space. And so I didn't really know why that existed. So yeah, I dug deeper and deeper, and I thought that if we had a system that multiple manufacturers were following, it means that we can help to keep their blinds full. We can start to provide work to where it's needed and also where it's most suited. And if there was ever a risk of a manufacturer going under, we don't have to send a project to that manufacturer. We can actually de-risk client projects by directing the flow of traffic or directing where the panels are getting manufactured. So we significantly reduce that risk for the client, which I think is quite different to how it's approached currently. And really what I was trying to achieve is just de-risking it for clients so they're not putting these large deposits down with a manufacturer and then finding out 6 months later that the manufacturer has gone and spent all that money, and then all of a sudden they go into liquidation, unfortunately, and they've lost their money.
So once the panels have been manufactured, do you have a network of builders around the country, or is this something that any builder can basically install?
Yeah, we do have a network. So like a network of build partners, and these are guys that we've worked with before or are working with. And I suppose they've become specialists in offsite panel installations and that sort of thing. So what we do is we attend all of our installs with builders and we help train them on how to install the panels. And because we're a product supplier to the project or to the building or to the client, we are effectively tied to the success of that project as well. And so we want to go along to those installations and make sure that the builder understands how to install things, put it together really well, and make sure that all of our taping and joining of panels and our structural fixings of panels are all done correctly and as per what's needed. And so, we've got these build partners that we've developed over the last few years throughout the country, but we're also growing that network as well. And so every time we do a new build in a new location with a build partner, we'll actually invite other builders along to see and demonstrate how to do these installations so that they're learning the process of offsite construction. So we're trying to build that network. But at the end of the day, it is a timber frame system. And so the adoption is really quick. So once a new builder sees it, they understand it straight away. It's not rocket science. It's something that builders are familiar with. They can understand it super easy. And it just means that it's a highly scalable solution nationwide to any and every builder.
And what are the sort of timeframes of building a house like this?
Maybe I'll give an example of a recent house that we did. So from time of contract for panel supply, so this is after the design of the house is done, from the time of contract to the time of installation to a weathertight lock-up structure on site was 2 months for one of our most recent projects. So in that 2 months, we procured material, we manufactured panels in about 4 weeks, including windows. This is a full lock-up airtight thermal envelope. So what that means from interior service cavity, vapor control layer, insulation, rigid air barrier, vented cavity on the outside, cavity closers, ready for cladding, windows installed. This whole envelope system manufactured off-site 4 weeks and then delivered to site and installed. And I think our installation for that house was 16 hours to a full weathertight lock-up structure over 2 days. So day one, we did floor panels. So this was a timber subfloor system on top of timber piles. So floor panels go down, took about an hour and a half, maybe 2 hours to lay the floor panels. Then the next day, we did the wall panels and then the roof panels and then all the internal framing as well. So 16 hours to a full weathertight lock-up structure. So windows installed, roof panels on, ready for roofing on, ready for cladding.
Now, a lot of our audience, Andre, are architects or architectural designers. What is the process and the benefits for an architect working with you?
There might be clients or architects out there that don't know exactly how to go about offsite. It's a new and growing trend or methodology of construction, and it's not highly known at this stage. And so I suppose what we can offer is help and support in that space and providing a system and a solution to architects and clients and builders. So we can help clients and architects with the specification of the system and getting it designed into their plans early. Quite often what happens with offsite manufacturers is they have architects or clients coming to them with a house that's been designed for 3604 frame and truss, and then the client or the architect says to the manufacturer, can you now build this offsite for us? And they're like, well, you've designed it with a truss system, and that you can't really offsite a truss system if you're talking panelized as opposed to volumetric. And so we're trying to put the tools into the hands of the architects and the client to be able to specify a system that's designed for offsite and helping de-risk the construction process or the manufacturing process. And I suppose the other time that an architect might want to look at a system like this is they've been interested in it before, they've looked at it, but they've maybe not had so much success with offsite construction. And so that's something that we can really help them with and help upskill them into how to design with our system, how to specify it. We've ironed out all of the wrinkles And we've got a lot of intel and knowledge that we want to share, a lot of IP that we want to share with the greater community. And I suppose the right opportunities to start looking or thinking about offsite construction. There's many applications for offsite construction, but a few that where it starts to make a lot of sense is in locations which are highly difficult to get labour to. So remote locations, islands, thinking about Waiheke Island, Great Barrier Island, or maybe the Marlborough Sounds, that sort of thing. So anything that has a really difficult location to get to and get labour and trades to, the more that you can do off-site, the more economic that you're going to make the construction project. Because shifting labour around the country is really expensive, having to pay for boarding and that sort of thing, or putting builders up in accommodation and trades up in accommodation. Other areas where it makes a lot of sense for offsite construction is where you're doing repeat volume. So like townhouses and things, when you've got standardized, repeatable typologies, that's where offsite construction can really, really improve things or really help to assist with the speed of delivery, the quality of the delivery. And in terms of speed, offsite construction can, I suppose, significantly speed up a construction project. And that really helps to reduce the holding costs to, say, developers and that sort of thing. So that's a really interesting avenue for offsite construction as well.
What about services? Are those all installed after you've got the house to lock up?
We've done that very intentionally. Services are something that are quite often very responsive to the design and the building site and the particular client, that sort of thing. So trying to install services in the factory, although it's possible, it means that everything has to be considered up front and then nothing can change. Whereas with what we're doing, allowing the services to be done on site through the service cavity means that changes can be made on the fly. It's not a lot of upfront cost. Also, if you're trying to install services off-site, you have to pay for the trade to come into the factory to install the services, and then you also have to pay them to go to site. And so you end up double dipping on that one trade, and it ends up more expensive. So it makes sense to do it on-site and just have that one call-out fee effectively.
Can you tell us about some interesting projects that you've completed with this system?
We've got Passive House that we're doing at the moment in collaboration with another architect. That's here in Oharu Valley in Wellington. That project, quite different. It wasn't our full Flexi House system. We've done the offsite design for that. But that's a building that's targeting Passive House Premium or Passive House Plus, I believe. So, that sort of thing is possible. What else have we recently done? We've done that house down in Lake Hawea, which we installed in 16 hours. Our show home that we installed in 13 hours. And we've got a lot of projects in the pipeline coming up, which are pretty exciting. We've got a 330 square metre project that we're doing in Waikanae at the moment. That's going to be a full weather-tight lock-up building in a matter of days, maybe 4 or 5 days, something like that. That project's on a concrete slab, fully insulated concrete slab. And then we've got another one up in Auckland that we're doing at the moment, another 200 square metre project. And, these larger projects include garages as well, so it's not just a small modular building that we're talking about. We're talking about 4, 5, 6 bedroom homes up to like 300-400 square metres. That's where some real efficiencies start to be seen with an offsite system like this, really getting to that weather-tight lockup structure super quickly.
Awesome. Now, wrapping up this discussion today, Andre, what do you see as your plans for the future and where do you see the business evolving over time?
Oh, I'd love to see panels on shelves at a merchant. I've always viewed, or I suppose had the dream of having the IKEA kit apart system for construction. So really, if you could imagine walking into, say, Mitre 10 or a merchant and just going through with a catalogue and being able to select all the components that you want. I want this window typology here and I want that there. And you might sit down with a designer like you would currently at Mitre 10 and sit down with a kitchen designer and design your kitchen. Why not do that with a house? Why can you not do that? it'd be amazing. You could sit down and design a house in half a day with a designer. They can give you an accurate bill of materials and an accurate cost to construction. And here's your builder that's local. He's going to assemble it for you. We'll have these panels and everything shipped to your site tomorrow. And away you go. That's flipping construction on its head. So that's where I'd love to see us go. That's our long-term view, I suppose.
Excellent. Thank you so much for your time today, Andre. It's been fantastic chatting to you.
Yeah, awesome. Thanks, Simon. Yeah, great to be here. Thank you.
Sharing knowledge is at the heart of our strategy to make buildings better for everyone. Sign up for our podcasts to learn more about creating healthy living conditions by protecting building structures from external and internal moisture damage. Thanks for listening. Looking forward to having you with us next time.